Hi guys, welcome back to my channel, and today I'm going to be showing you the solution for milk sum. The way that this problem works is that Farmer John needs to figure out how much milk he can get from his cows, the maximum. And each of his cows starts out with a certain milk they can yield each minute. Each of his cows start on the milking machine, and after each minute, he unhooks one cow until they're all gone. So the idea is to keep the cow that yields the most milk on the machine for the most time. So in this case, you'd first take out 1, then 2, then 4, then 6, then 10. And the further complexity in this problem is that you're given Q queries. And in each of these queries, you change the milk yield for one of the cows. In this case, milk 2, which is this one, now yields only 1 milk. And you have to calculate how much is the maximum milk Farmer John can get from the cows after this transformation. And it gets reset after every query. So, how might we do this? Well, since we need to make sure that the ones that yield the most milk go first, we can quickly determine that it has to do something with sorting the list. But now we have to do these different transformations to it and quickly determine how much milk it yields. Looking at the problem, if we can, and the constraints, if we can make a solution that is n log n or O of n, it will clear the solution. So let's look at the first query. If you change cow 2 to 1, which is this one, what will happen? Well, now we don't want 1 to be here. So the ideal order for taking off the cows is now this. So what can we tell from this? First of all, this is being moved here, and all of these are being shifted by 1. So we need a way to figure out how to calculate this in log n or linear time. So calculating the difference that Farmer John might be able to take from just that one cow is simple subtraction and addition. You subtract this times the time and add this times the time. But now you have to figure out what to do for this. Well, if it becomes less in this case, then all of these cows move up. So we just have to add all the sum of all of these to our output. But if we take a case where the new value is more than the old value, like in this case, 4, which is 2, becomes 5. So the new ideal milking order is this. So in this case, 2 gets moved here in front. And now, again, we can do the simple calculation for 2 and 5, but now what is moved is 4. And in this case, since it's moving backwards, you just subtract it. So if it's going down, you subtract it, and if it's going up, you add it. Now, the only other thing we need to find is how long, to be able to find quickly, is where the new value comes in this array, which is easy. We can do it with binary search because it will already be sorted. And we need to be able to quickly determine what other things to subtract or add, which in this case is a segment of the array. Now this is a perfect application for prefix sums, which is exactly the solution for the problem. This will make the solution O of n log n, because first we sort it, and in the loop, which is O of n, which is O of q long, we will do a linear calculation for calculating the prefix sums, but we will need binary search to figure out where it goes. So now let's look at the code. Here is the code. And this last true is simply binary search. It might look a bit different from classical binary search, but it's the same thing as binary search except using a for loop. And it calculates what is the element in milk values that is less than or equal to whatever value we pass to it, which is exactly how we're going to calculate where our transformation sends the new milk values. Now, if you look to where we are reading the input, we simply read everything into the milk values, which we'll use for binary search, and the def, which is the original thing, which we'll use for querying the different milk values. Then we sort it, and we construct a prefix sum of the original array so that we can calculate this difference when it's shifted. Now we read in each of the queries, and we use last true to see where the original position is and where the position after is. Now we go f++ because that is where it will be sent in the array. And depending on whether it's larger or less, you subtract 1. You subtract 1 from that, and that's simply done by a binary expression. Then we start calculating ands by the simple calculation of the new position of just the cow we changed. And after that, we have to calculate the prefix sum, which requires some if statements, because if it's greater, then we subtract it, and if it's more, then we add it. And this is all that there is to the solution. There's binary search and prefix sums. Now, if we submit it to the USACO website, we can see that it gets everything in the right order. And there you go. It solves everything fully, and it doesn't use very much memory. Memory is never a problem here. All that we have to store is the prefix sum and the original array, which isn't very much. And if you look at the solution, it's well below the time limit for this problem, which means that though this is the most optimal solution, in the contest, it would have also been sufficient to use a solution that's not as perfect. Okay, thank you for listening. I hope you liked it. If you liked it enough, please like and subscribe, and I'll see you next time.